So I think you already have seen these switches, right? So we have to have a switch, and then we have to match with the schematic. So we got this schematic from POS, we got this image from POS, and then we connect each of the switch from here to the VCC through the register 220, and we pretty much did that here, right? For the first two column, I'm sorry. So if you need more than two switch, you pretty much can do the same for every switch, right? Run a register from here to the voltage 5, because all these points are same, right? Remember all these columns are short here, so it doesn't matter from which point you run the register. Now at the bottom, you run these same column, you run a wire from those column to the ground. Similar to this one, right? Remember, for all these switches, we connect this wire and then we run it to the ground here, right? That's exactly what we do. Now remember, after this lab, as I said, you will never see the switch again in the schematic, because we assume that you already know the switch, okay? How many switches you need. Now let's look at the circuit and see whether we understand how we actually build this circuit from the schematic. Now look at these wirings, okay? So let's say from switch A, we run a wire from the switch A to pin number 1, right, of 7400. Now you can directly run this, but sometimes to make the circuit more organized, we do it in a little bit in organized fashion. But you can always do it directly, okay? This is what we do. Look at this. This is our switch 1, right, which is switch A also. So we run the wire, white wire. Do you see the white wire here? We run it from all the way from here to here, and then the same wire is connected to the green one, right? How it is connected to the green one? Because remember, all the columns are short, right? So if you have a wire connected here, and if you connect any other wire in the same column, it's connected, right? That's exactly how the breadboard works. So this wired wire is actually connected to the green one, which again went back all the way up to here, and then this green wire is actually connected to the yellow one, right? Do you see this yellow wire? And through the yellow wire, we actually running the wire from pin number 2. So basically all we did is we took one switch connected to the pin number 2, we took the other switch through the chocolate, blue, and the red, we connected to the pin number 1. So based on this circuit, you can actually take any of this switch and connect it to the pin number 1, and other one is pin number 2. Basically these are two inputs, right? These are the two inputs. Now instead of making it super organized like this one, you don't actually have to do it like this. What you can do is you can directly run a wire from this pin to this pin, because all you need is just connection, right? But we try to make the circuit a little bit more organized. So that's why we sometimes, we run the wire in an organized fashion, but you don't have to do it. So that means you don't have to do it using 3 different wires. So you can directly, all you need to do is run a wire between the switch A to pin number 1 or pin number 2, or between the switch B to the other pin, right? The pin number 1 and 2. So you can just use a single wire to do that, right? So you can just do that using a single wire from pin number A to pin number, switch A to pin number 1, or switch A to pin number 2. So these are my pin number 1 and 2, right? So this is how we count, right? So pin 1, 2, 3, 4, 5, 6, 7, and then starting from here, 8, 9, 10, 11, 12, 13, 14, right? Now, we see that there is another wire running from pin number 3 here to pin number 1 of 7400, right? So look at that pin. This is my pin number 3 here, right? This is my gray wire here. Do you see that? The gray one is actually the one which is running between pin number 3 and pin number 1 of pin number 3 of 7400, and then pin number 1 of 7404, right? And then we actually check the output in both here and here. How do I know it? Because see, we actually have LEDs in 2 different points. Now every time we have an LED, that means we want to check the output of the circuit at that point, because what LED does is LED lights up when the voltage is 5. That means when this is a logical 1, right? Because in the digital circuit, all that matters to us is whether this is 1 or 0, right? So once we plug the LED, we know that if it is lighting up, that means it's 1, right? If it is not lighting up, it's 0. So all we need to know that, right? So that's why what we did is we connected an LED to both of these points. So one is here, another is here, right? So look at this LED. So this is actually connecting through a register, right? See, there is a register 220 and then an LED. The reason we put a register between the connection and the LED, because register actually controls the current passing through the LED, right? That actually saves the LED, because otherwise if you pass the full current there, LED might be burned out, okay? So that's why we use the register. So this is what we did. Look at this. This is actually connecting to the pin number 3. So this dot means this line is actually connected to this line, right? Now that actually means you can connect this point from either pin 3 or pin 1, because pin 3 and pin 1 is actually the same thing, because you run a wire, right? You see what I'm saying? You can either run the point from pin 3 or you can run it from pin 1. It's the same thing, because it's connected to both the pin 3 and pin 1 both are connected. So what we did here is we connected this from pin 1. See the pin 1 here from 7404? We connected this register to a free column. Why we connected to the free column? Because if you do in the same column, like it will be short, right? You can't do everything on the same column, right? If you both head of the register is on the same column, that means what? You are just shorting it, right? Connecting the both head, the both side together. So you run to a free column, and from the same column. Now the free column means this column was never used before, right? It's a free column. Now we pretty much run it from here to the free column, and from free column we actually connect our LED to the ground. See, the LED is connecting from one side to the register and the other side goes to the ground, right? Now if you look at the LED carefully, once you go to the lab, you'll see that with each LED, it will be on your package, but in each LED there are two legs, right? One leg is a little bit shorter than the other one. It will be always the case that one leg will be a little bit shorter than the other leg. Now the shorter leg always goes to the ground. Okay? See the LED, it looks like there is one leg is a little bit shorter, right? You see the LED is a little bit inclined to the ground side because this leg is actually shorter than the other leg. Now same is here to the other side. We actually connected another LED on the other side. See, from pin 2 we run another register to the LED, right? We did the same here. See, from the pin 2, this is my pin 2, right? See, this is my pin 2. We actually run a wire to a free column, because we run a wire to the free column and we run a register from there to a free column and then run the LED. Now these are the two outputs that we'll be checking for this circuit. This is actually a very simple circuit. Now once you are done with the circuit, you will test it, right? Before you test it, make sure you have all the register, all the ICs with the power. Remember, we have to power the IC. How do I power it? Look at the ICs. For every IC, we actually have 2 points to power. For every IC, 1 point will be connected to the VCC, which is voltage 5, and 1 point will be connected to the ground, meaning 1 pin, right? Point means pin here. So how do I know which pins need to be connected? We'll get it from the data sheet. Remember, we have a data sheet. If you look at the data sheet for the IC, you will exactly know that which pins needs to be connected to the VCC, which pin needs to be connected to the. Can you check the data sheet of 7400, which is located probably right after page number 109 in your manual? Can you check what is the pin for, what is the VCC pin for 7400? It's actually in the order, okay? Can you check what is the pin for VCC and what is the pin for ground for 7400 on your manual? That is actually located in page number 1.74. You have 7400, right? It's actually in sequence. That's in page number 107, I think. Can you see the schematic at the very top left? There is a schematic there, right? What is the pin number? Did you all find that 14 is the pin number to connect to the VCC? It's at the top left corner. Do you see the schematic? I'm saying the data sheet. It's page number 107, and you see the VCC is the pin number 14 is VCC. Page number 107. Do you all see it? Mm-hmm. That's where actually we started our schematics. I'm saying the data sheets. Do you see it? Now remember, For every IC, there will be two pins. One needs to be connected to the VCC, one needs to be connected to the ground. And both of those pins will not be in the circuit because your circuit will never tell you where is the VCC and ground for the IC because that's like pretty generic. You know what I'm saying? So you have to always check with the data sheet to see whether your ICs are powered up. Now, based on that information, we have to make sure we powered up. Look, do you see this gray wire in the pin? This is my pin number 14, right? For this IC. See the gray wire is running from here to the VCC. That's my VCC, okay? And what is the ground? What is the ground pin? Pin number 7, right? Did you all find the ground pin? Page 107. Did you find the data sheet? It's the pin number 7 is ground, right? But remember, it will be different for every IC. Don't assume that it will be always pin number 7 and 14. So that's why.
So are we not supposed to look at the LS? We're supposed to look at the 7.0
LS doesn't matter. It's like it's actually a manufacturer symbols. Okay. In the lab, you will also see different ICs. Instead of LS, there is something else. Okay. All that matters is at the beginning whether there is 7.4, and at the end there are 00 or 02 or 04 or 08. Okay, something. All that matters is the IC number. Okay, don't look at the letters. It doesn't matter to us. Now, okay. Now, what is the ground pin again? Did you all find the ground pin for that? Yes. It's at the top left corner. You see that? It's written GND for the ground and VCC for the voltage 5. So the ground pin is pin number 7. So that's exactly. Do you see this yellow wire here? Look at this yellow wire. That's my ground, right? For the IC. Now remember, these two wires were not there in the circuit. Because your circuit will never tell you what pin you need to be connected to the VCC and ground because we assume this is like default. So you have to always check whatever the IC you are using. You have to go to the back of the manual, starting from the page number 107. Just check your data sheet to know it. Now, what is the other IC we have? 7404, right? Can you go to the 7404? It's actually in sequence. The numbers are in sequence. Go to the 7402 and tell me what is my VCC pin and what is my ground pin. Exactly 14 and 7, but don't assume this is the case all the time, right? This may be different. A lot of ICs have 7 and 14 at the VCCs and ground, but there are exceptions, okay? Now, so for my 7400, look at this. This is my 14, right? We ran a wire from here to VCC. Now, you might be wondering why I went here. I could have gone here, right? It doesn't matter because any of the points, remember all these points are short, right? All the whole row is the short. Doesn't matter which point you connect, right? Somebody might be thinking, oh, I have to go to the, it doesn't matter at the beginning. Okay. And also, look at the pin number 7 of the 7404. See, the pin number 7 is also grounded, right? Now, these two connections will always have to be there, but these will not be in the circuit. Now, one more thing is the board that we used to build this circuit. It was a Radio Shack board. I think your board is different. Some of the Radio Shack board that didn't have at the top, that did not have the left side and right side connected. Okay, and to make it connected, that means usually in any of the board, this whole row is actually short. Do you see what I'm saying? But in the Radio Shack boards, this side is short and this side is separate and short. So we connected this one through these green wires. See this green wire here? So you will not need these green wires in your circuit. This is something that we have done only for that board because that board is exception because they don't have the left side and right side connected. They might want to have like more rows than 1 or 2, right? If you don't have it connected, they have one at the left, one at the right. Again, you probably can use like 4 different voltages. I'm saying, it's not probably for the digital circuit, for the other circuit. Breadboard is not only for the digital circuit. It can be used for other circuit as well, right? Okay, let me stop this discussion here. Let's go to the lab and let's see whether we can start our lab 3 as quickly as possible. Now remember, you have to have the manual, you have to have the tools, and I will also give you a kit, parts kit, where you will have all the ICs that you will ever need in this class for all the labs. So make sure you have to have all of those separate, and especially the kits keep it safe, because there are, all the ICs have legs, right? If you keep it like, under pressure, all those legs get bent, okay? So make sure you have it all the time you are here for digital circuit class. Let me stop this discussion so that we can quickly start the lab. I'm sure that this will help you understand and start the lab. And for each and every lab, we will have a schematic and we'll have an image. But you now know that how to use it, right? Basically, you will be using the schematic to build the circuit, but the image is something which will help you to see how it will look like. It may not be exactly same, right? Because, as you know that, for an example, at the top row, all the points are like VCC. It doesn't matter which pin we connected and which pin you connected at the top row, right? So some of the things may be a little bit different here and there, but logically, it should be matching with the schematic, and that's all we need. Let me stop here so that we can go to the lab.